Assalamu alaikum wa rahmatullahi wa barakatuh. Hello civil engineers and welcome to Civil 53 Net. In the previous lecture we discussed the following topics: units, creating a new model, selecting the code and setting up the grid system. The essential first steps to get your project ready in ETABS. Today we are diving into step 3, define. One of the most important stages in any structural project. As we know, every project follows 7 systematic steps: units, file, plus code, define, draw, assign, run, and resolve. In this lecture, you will learn how to define materials, sections, loads, and load combinations in ETABS, the foundation for creating a reliable and efficient structural model. By the end, you will have the tools to set up your model like a pro. So let's get started and bring your project one step closer to reality. So here we are in ETABS. The first thing we will do is to set up the units. So click here on units, consistent units, since we are using meter, and Celsius. Okay. As we said in today's video, we will be talking about define section. So here we are, this is the define. We will be talking first about material properties. Click on it. Now as we know that in structural design, we mainly use concrete and steel. First, we will start with the concrete. Just let me give you a brief interview about the concrete grades. Concrete grades are defined by their characteristic compressive strength, FCU, at 28 days, which tells you how much load the concrete can safely carry. The common grades FCU 200, 20 MPa, light residential or low load structures, FCU 250, which is 25 MPa. Most normal buildings often considered the minimum standard for structural concrete. Also, we have FCU 300, which is 30 MPa, multi-story or higher load structures. We also have FCU 350 and 500 for bridges, high-rise buildings, or heavily loaded beams and columns. I have talked in details about this topic in my previous videos, so I will put the link in the description or it appears here in this eye icon. Now let's get back to our topic. To define our concrete, click on this 4000 psi. It's if you are using US templates, it's gonna be called 4000 psi. But don't worry, just click on it and click on modify. From here, give it a name like material name. We will be calling it FCU 250. 4000 psi is the US equivalent of roughly 25 to 28 MPa. It's just a different unit system. And here you will enter this weight per unit volume. It's going to be equal to 2.5. Since we are working in ton per meter cube, that's why we entered 2.5. And here in models of elasticity, the models of elasticity depends on the design code. For example, in US code, the formula is going to be like the following. E, which is the models of elasticity, equals 4700 under root FC dash. This FC dash is the value of FCU, which is 250. And according to IS, Indian Standard Code, and Egyptian code, the models of elasticity equals to E equals 4400 under root FCU. After using the formula, you will get the value here. Sorry, you will get the value 2250. 1, 2, 3, 4, 5. So in this window, all you need just to change the material name FCU 250 according to what you are using, and then you will enter the value for your weight per unit volume, which is 2.5 tons per meter cube. Concentrate on the units. We are using tons per meter. So this value represents the stiffness of the concrete, how much it resists deform under load. ETABS use this value along with the material weight and geometry to calculate deflections and internal forces accurately. For example, models of elasticity equals to 2250 ton per meter square, corresponds roughly to concrete with FCU 25 MPa in the unit system you are using. Now click here on Modify Show Material Property Design. Here we will enter the value for specified concrete compressive strength FC dash. This value is usually calculated by dividing the characteristic strength by a safety factor. So, since we are using FCU 250, our factor of safety is equal to 1.25. This is the partial safety factor for concrete according to many codes like IS code or similar. This makes the design strength slightly lower than the characteristic strength, providing a safety margin in case the material is weaker than expected. So now to calculate this value, formula is going to be like 250 divided by 125, which is the factor of safety. The units are tons per meter square, do not forget that. So first, 250 divided by 1.25, it's equal to 200 kg per centimeter square. Now to convert it into tons per meter, we will multiply by 10. So final value is going to be 2000 tons per meter square. Now let's clean this, and then we will enter the value 2000. Click on OK. OK. As we can see now, it becomes FCU 250. OK. Now we will define steel. Click on this A992FY. This is the templates in US. Just click on it and click on modify. Give it a name FE 415. For our small residential building with the concrete FCU 250, we will use FE 415 steel for reinforcement. It's strong enough, widely available, and cost efficient. In ETABS, we defined it by entering the density, which is weight per unit volume, 7.85 tons per meter cube, and modulus of elasticity is gonna be 2 millions. 1, 2, 3, 1, 2, 3. The modulus of elasticity E for steel is almost constant worldwide, unlike concrete, which depends on grade. We won't modify much on steel since we will not be designing on ETABS. We will just make a model. For now, click on OK. OK. So alright, we are done with defining the materials, both concrete and steel. Now we will move on the next step, defining the sections. First, we will define frame sections, starting with the column. For example, let's assume that we have a column of 13 to 60. Later, we will also define beams and slabs. So click here on define. Since done with material properties, now we will define a section, which is column section. So click here on section properties, frame sections. You can click here on concrete column and modifier, but we are going to create a new one by clicking on add new property. Click on concrete rectangle section. Let's give it a name, C30 into 60. Here we will enter the value for depth, which is 0.6, the height of the column, and width of column is 3. Please note that when defining a section, ETABS allows you to apply modifiers for different properties. For columns, codes like IS456 or ACI offer recommended reducing stiffness to 70% to stimulate real-life behavior after cracking. Without these modifiers, ETABS will assume uncracked concrete, which can overestimate stiffness, giving unrealistically low deflections. So we will set our modifier. Click here on modifiers. We will change this torsion constant into 0.7 and moment about 2 axis 0.7 as well as about 3 axis 0.7. Click on OK. Regarding this, include automatic rigid zone area over column. We will be talking about this later on, but this one, let me explain it fast. Some people, when they draw on AutoCAD, they draw the XF file, then they import it here to ETABS. So let's assume that this is our column in AutoCAD, and write it like this. And this is the beam between them. Before, ETABS doesn't have this option. So we used to extend this beam to the center of the column so that the column can take the loads from the beams. But for now, since we have this option, there is no need to extend the beam to the center of the column. We just place it here on the face of the column. And before that, we used to draw a line like this. We call it rigid, with modifiers mass and weight of 0, and modifiers other values are very big, like 700, 7 million, and so on. And then we extend this beam to touch this line. This way, the column will take the weight from the beam. But with this option, there is no need to do this rigids. I will be talking about it in more details later on. For now, we just learned how to create our section column. Click on OK. Now let's say that you want to add another column or a new column. Then there is no need to repeat everything. Just add a copy of the property. And then you will name it, for example, 30 into 95. Then you will just change the depth into 95. If you click here on modifiers, it's already done because we make a copy. So click on OK. And if you want to modify, just click on it and click on modify. Then click OK. The second section we will define is beams. So let's create a new beam. Click here on add new property, concrete. We will name it, like, let's say that we have a beam of 25 into 60, 25 into 60 centimeters. So the depth is 0.6 and width is 0.25. Here also you should set the modifiers. We will change only for about to access the moment, which keep it 0.5, and here also 0.5. Click on OK, and then OK. Click here on add a copy property and name it P12 into 60. So depth is 0.6 and width is 0.12. As we know that most of the beams are 25 into 60 or 12 into 60. Click on OK. Now let's say that you want to modify this to add centimeter here, for example. There is no need for that, but it's up to you. Centimeter. Just want to show you. Click on OK. So done with columns and beams. Click here on OK. Now we will define slabs. So define section property. Slab isn't a front section, it's a slab section. So click on slab section. Now we will add a new property. Let's name it, for example, as 20. Like thickness is 20 centimeter. And here we will give the thickness 0.2 since it's 20. And then we will set the modifiers. Sorry, it's here. It's gonna be for bending M 11.25 then 0.25, 0.25. Click on OK. OK. Now let's say that you want to add another slab. Just click here on add a copy of property and we will give it a name S. Let's say it's 14 centimeter and then change this to 0.14. The modifier is already set. Click on OK. OK. So done with the slab. Now let's define a wall. To define a wall, click here on define section properties wall section. Add a new property. Let's name it W25 centimeter. Thickness is going to be 0.25. Then we will set the modifiers 0.35, 0.35, 0.35. Click on OK and then OK. If you want to add another wall, just click on add a copy of property and we'll just give it a name W12 centimeter. And then see the modifiers 0.3. Click on OK. Click on OK. So with that, we have defined all the sections we need: column, beam, slab, wall. Now let's go to define our loads. So here again, click on define and then search for load patterns here. As we can see, we have dead and live, and the value for dead is 1 and the live value is 0. This is because we want ETABS to automatically calculate the dead load for us. But the other loads, we will be doing the calculation. So now we need 2 more loads, which are like we need dead load, live load, floor cover, and walls. So let's add floor cover. We will name it FC and we will make the type other, give it a value of 0, then add a new load. Load of walls, other, add a new one. As you can see, now we have the dead, live, floor, wall. So then we're defining load patterns. So why the dead load have the value self-weight of multiplier by 1? That means I'm asking ETABS to calculate automatically the self-weight or the on weight of the column, beam, and slabs. If you put this value into 0, like say for modify, click on 0, then modify. This way means that you have to calculate the on weight of column, slab, beams manually. So you will be using this formula for column. It's equal to width into height into density of concrete. So for slab, it's going to be S equals thickness of slab into density of concrete, and so on. So for each, remember, you will have different dimensions, and that's going to be difficult. That's why we keep this value as 1 to ask ETABS to calculate the on weight automatically. But for the live load, the value is changing. It's not like the dead load. It's self-weight. It's according to the type of building, whether residential building, commercial building, hospital, school, and so on. Same for the floor cover and walls. They are not constant. So after defining the load pattern, just click on OK. Let me clear this one. The last step is to define the load combination. Just click on define and here look for load combination. So add a new combo. First combo is going to call ultimate. Then dead load factor is going to be 1.4, and then we have floor cover also 1.4 and walls also 1.4. For live load, it's 1.6. So what are these values? As you remember this formula, I think all of us should know it. WS ultimate, it's equals to 1.4 bracket dead load plus floor cover plus walls plus the bracket, then plus 1.6 live load. So this is our ultimate load. We use this load to design columns. Now just clean it. Click on OK. Now we will add a new combo, which is the working load. We use working load for designing foundations. So click on working, then add. Here we don't have to add scale factor, just life load, low cover walls. Okay, now we have then defined ultimate and working legs. Click on OK. That's all for today's lecture. We have defined materials, sections, and loads in ETABS. And now our model is ready for the next step. If you found this video helpful, please like, share, and support the channel. It really helps me create more tutorials for you. Next Thursday at 9 PM KSA time, we will continue with drawing in ETABS, where I will show you step by step how to draw beams, columns, and slabs. Thank you for watching, and I will see you next week, inshallah. Goodbye.